You have probably heard people explain artificial intelligence, machine learning, and deep learning with fancy definitions and flowcharts. But after all that jargon, you're still left thinking, wait, so what's the difference? Really? In this video, we are going to explain these terms with concrete examples that would finally make these concepts click and stick with you for good. Welcome to AI Club Pro, your go-to channel for making AI concepts clear and accessible. Let's start with a small description of what AI, ML, and DL mean, followed by a longer explanation of each of these terms using concrete examples. Think of them like a family. Artificial intelligence is the parent, and any method that makes machines seem smart or behave intelligently can be called AI. Think of machine learning as the child who learned an impressive skill. And the skill is that it can learn directly from data to improve its performance. Deep learning, on the other hand, is the genius whiz kid, which uses a very specific advanced form of machine learning where it uses multi-layered neural networks to handle complex tasks. So let's break it down with some concrete examples. Artificial intelligence as an idea was born in the 1950s. Researchers started asking a question: can machines think like humans? For those days, that was quite a visionary thing to ask. The goal wasn't just to build faster calculators to automate simple tasks, it was to create intelligent machines, tools that could mimic human decision making, planning, and reasoning. But here's the important part: early AIs did not learn. Instead, they followed intricate sets of rules which were handcrafted by human programmers. Think of it like writing a giant instruction manual for a robot. Every situation had to be anticipated in advance and the response was scripted. So let's look at some examples of AI. These are all examples of AI but do not fall under either machine learning or deep learning. Think of a computer playing chess, where the computer is programmed explicitly with rules and strategies like, if your opponent does X, respond with Y. This is classic AI. It looks smart but doesn't actually learn or adapt from experience. Early customer support chatbots were also something like this. They were strictly programmed to reply to some keywords or specific questions. They might seem smart, but their intelligence comes entirely from predefined scripted responses. Another example is games like Pac-Man, where the opponents are programmed with fixed patterns of reactions which are not learned behaviors. For example, Ghosts and Pac-Man follow a specific coded rules and they appear to be intelligent but without any adaptive learning involved in the process. So fast forward to 1990s and computers were getting faster and more powerful and sophisticated. So scientists and researchers began to wonder, what if we don't tell computers exactly what to do step by step? What if instead we simply feed them with lots of data and let them discover the patterns on their own? And so machine learning, the skillful child of artificial intelligence, was born. Let's look at some everyday scenarios where machine learning is used. So banks, for example, use simple machine learning algorithms like logistic regression or decision trees to predict if a borrower will repay the loan. These models have learned from past data of customers and how they were approved or rejected loans. They understand the complex interplay of rules based on things like financial history, employment status, existing debts, etc., to make predictions. The difference is that no one hand-coded these rules. The algorithms learned these rules automatically based on historical data. Such a task typically does not need a deep neural network. A second example is in retail companies, which use algorithms like k-means clustering to analyze buying behaviors and demographics to group their customers into segments. This helps the businesses to provide customized promotions that enhance your shopping experience. And again, such kind of segmentation typically does not need deep learning. Another example would be fraud detection. Think about a time when your bank called you to confirm if a transaction was yours. Banks and payment providers are always on the guard against fraud, and they use machine learning algorithms such as random forest or support vector machines for this. These tools can scan transaction patterns like how often you spend, typical transaction amount, and even geographical locations to spot any unusual activity. So then in 2010s, computers got even faster, and a technique called deep learning exploded in popularity. Deep learning uses neural networks, which are layers and layers of interconnected nodes, loosely inspired from the human brain cells, to tackle incredibly complex problems. So let's look at some everyday scenarios where deep learning is used. So one of them is image recognition and classification. Have you ever wondered how Google Photos effortlessly sorts all your images by faces? It can even sort the images of your pets. Traditional machine learning approaches, which depend heavily on manually defined features, struggle with such tasks because images are complex and varied. Deep learning, on the other hand, can automatically analyze millions of pixels and detect subtle patterns to accurately categorize each picture. This is something that traditional methods simply cannot match. Another example is facial recognition. Consider unlocking your phone by just looking at it. Your phone scans your face and uses deep learning neural networks to quickly check your unique facial details. These systems recognize you reliably even if your appearance changes, like, for example, growing a beard, changing your hairstyle, or wearing glasses. Another example is language translation. Tools like Google Translate instantly convert text from one language to another, which can be quite handy when you travel to a place where the language is different. Traditional machine learning struggles because languages are complex and filled with nuances like idioms, slang, different meanings based on context, etc. Traditional approaches typically just rely on strict rules and predefined dictionaries, making it hard to capture these subtleties. Deep learning, however, can automatically learn the context, interpret the meanings accurately, and handle grammar variations, providing translations that feel natural and easy to understand. Generally, deep learning requires significantly more data compared to traditional machine learning algorithms. While traditional machine learning is simpler, faster to train, and works well on smaller datasets, deep learning thrives on large amounts of data that enables it to tackle more complex tasks and achieve higher accuracies. Think of artificial intelligence as the dream, machine learning as the method, and deep learning as the powerful technique that is currently driving the most exciting AI breakthroughs. Next time you hear these terms tossed around, you'll exactly know how they are related and why deep learning is the cutting edge technology behind today's most impressive AI achievements. Thank you for watching, and please subscribe for more clear and concise explanations on AI topics.